Every device on the internet, your phone, laptop, smart TV, needs an address so the data knows where to go. That address is called an IP address. And right now, the internet is migrating from an old version to a new one. Today, we will cover IPv4 and IPv6, what they are, why we ran out of one, and what comes next. IPv4 is what most people picture when they hear IP address. It looks like this: four numbers separated by dots, each between 0 and 255. And under the hood, that's 32 bits, which gives us around 4.3 billion possible addresses. In 1983, that seemed like plenty. The internet was a small research network. Nobody imagined billions of personal devices. Fast forward to today, there are over 15 billion connected devices. We ran out. In 2011, the last block of IPv4 addresses was allocated. To stretch things out, we invented NAT, Network Address Translation. Your router gets one public IP from your ISP, and all your home devices share it using private addresses like 192.168.x.x. It works, but it's a workaround, not a fix. IPv6 was created to solve this one, and it looks like this: 8 groups of hexadecimal digits separated by colons. Instead of 32 bits, IPv6 uses 128 bits, giving us 340 undecillion addresses. That's 340 followed by 36 zeros. With this, we could give every person on Earth 50 octillion addresses and still not run out. The problem is permanently solved. Also, IPv6 addresses can be shortened. Leading zeros in any group can be dropped, and one run of all zero groups can be collapsed to 2 colons once per address. So this address simply becomes 2002 colon db8 colon 50. Here's how they compare at a glance. Two highlights worth mentioning for IPv6. First, no more NAT. Every device gets its own globally routable address. The end-to-end internet as it was originally designed is restored. And IPv6 has SLAAC, Stateless Address Auto-Configuration. Devices can generate their own IPv6 address automatically using the network prefix and their MAC address without needing a DHCP server. So the real question is, if IPv6 is so much better, why is IPv4 still everywhere? 3 words: compatibility, cost, and inertia. IPv4 and IPv6 aren't directly compatible. A pure IPv4 device can't talk to a pure IPv6 device without translation. Most networks are in dual stack, meaning both protocols run simultaneously, which adds complexity. Upgrading routers, firewalls, and legacy software takes time and money. And because NAT kept IPv4 alive longer than it should have, the urgency never reached a breaking point. Also, some older softwares have IPv4 addresses hard-coded into it. Migrating isn't just a network change. It can require application-level code changes too. The good news is adoption is accelerating. Google reports over 45% of its traffic now arriving via IPv6. Mobile networks and cloud providers are leading the charge. The direction is clear. IPv6 is the future. That's it for IPv4 and IPv6. Like and subscribe for more networking videos. See you next time.